addition of the vectors. Okay, so addition of the vectors, a vector A is from A to B and vector B is from B to C, and new vector C from A to C is represented as a sum of the A and B. Two vectors A and B, it is represented. Okay, so this is called addition of the two vectors. See, AC is represented as A bar plus B bar. A bar plus B bar. So if you are taking see, AB bar plus BC bar is equals to AC bar. The vector AC is the sum of the two vectors AB and BC. And here the terminal point of the first vector and the initial point of the second vector are equal here. And here CA, whenever you are taking in an opposite direction, this is CA. So their sum will be equals to 0. 0 वेक्टर 0 हो जाए ना, उधर से जाके दोबारा सेम प्लेस में आ गया है. So AB plus BC plus CA is equals to AA. AA is nothing but null vector. It is null vector or 0 vector. We can call it as a 0 vector because A से start करके A to B गया है, B to C गया, C to A. So now instead of B in opposite direction, if you are taking, it is represented as a minus B bar. B to C upwards is plus B, means B to C downwards is minus B. So now here A to C dash is represented by A bar minus B bar, difference of the two vectors. C bar is equals to AB bar plus BC bar, but BC bar is represented by minus B bar. So the vector is A bar plus B bar. A bar minus B bar, sorry, A bar, small a bar minus B bar. So difference of the two vectors, this is addition and difference whenever you are taking into consider, same way you are going to get it. Okay, समझ में आया? Suppose a water flow is there here, a point O is there and water is flowing. You are swimming from here to O to A. Here, is it visible to you that? And this vector and direction is there, OA1. But whenever you are moving, water flow is there, automatically you will be moved towards the water flow when your force is less. So that point you are going to reach. From O to C you are going, and A to B is another vector. So addition of the vectors in your like this, whenever you are taking here, water flow is in the direction of the B bar vector. And your displacement will be A bar plus B bar. So here, when you take this O to B and B to C, that is also equal to O to B will be equals to the A to C because parallelogram. This is called parallelogram law, but previous one is triangular law. Previous one is called as a triangular law. So here in this case, if you are taking here, OB is equals to B bar hoga and BC is equals to A bar hoga. So this is the diagonal length will be equals to A bar plus B bar. So parallelogram, whenever you are taking, in the parallelogram, two adjacent, see here, parallelogram law of the vectors. The sum of the two vectors representing the adjacent sides of the parallelogram is given by the diagonal of the parallelogram passing through the common point of the two adjacent sides. So side by side, if two vectors are given, the diagonal will be taken into consider A bar plus B bar, and it is called as a obviously parallelogram law. समझ में आया ना? So same है, because AC distance and OB distance, the distance AC and OB whatever you are taking will be same. That's why it is called a parallelogram law. AC distance and OB distance both are same, that's why it is B bar. And as per the triangle law, OA plus AC is equals to OC. OA plus AC is equals to AC. AC can be written as OB. AC का प्लेस में OB लिख सकते हैं. So OA plus OB is equals to OC हो जाए. So the first one is parallelogram law, second one is triangular law. So both are addition of the vectors only. So these things are very simple here. Commutative property of the vector of addition. A commutative property means if you add the vectors in any direction, a bar plus b bar is equal to b bar plus a bar. So both are same, you are going to get. That is only called the commutative property of the vectors. So triangular law of addition, whenever you are taking a bar plus b bar, you can write ab plus bc. Next, if you take the triangular law, ऊपर वाला ab bar is equal to dc. So ad equal to b bar, dc equal to a bar. So here b bar plus a bar लिखते हैं. So that is also equals to the same ac. A to D गया है, D to C गया है. That is equals to also AC. AC equal to, in that case triangular law use कर लिया तो in the triangle ADC a B bar plus A bar you will get. But the same vector can be written as A bar plus B bar and same vector can be written as B bar plus A bar in the different triangle if you are taking into consideration. So that's why both are equal here. So that's why it satisfies the commutative property of the vector addition. Okay. Next, additive identity. Additive identity is nothing but if you add the null vector, zero vector to the any vector, same vector you are going to get. So null vector is act as a additive identity vector in case of the vector addition. Associative property means a bar plus b bar plus c bar is equals to a bar plus b bar plus c bar. Consider the three vectors here. AB is one vector, A to B, B to C is another vector, C to D is another vector, that is C. Now if you have taken A to D and A to C, A to C will be written as A bar plus B bar. A to C will be written as A bar plus B bar using the triangle. And A to C is there and C to D is there. So A to D can be written as A bar plus B bar plus C bar. A to C is given and C to D is given. Blue color में green color. So तो तीनों का ऐड कर ले तो A bar plus B bar plus C bar आएगा. So AD we can write it as A bar plus B bar in the brackets plus C bar. If you take like this, okay. So same thing you keep it aside, and now you take the triangle BCD. Here BD can be written as B bar plus C bar. B to C, C to D. Green color, red color will give you the blue color vector. So B bar plus C bar. And A to B, B to D ले लो. A to B को A bar बोलते हैं, B to C को B to D को B bar plus C bar बोलते हैं. So A bar plus in the brackets B bar plus C bar is represented as a AD vector. So in both the cases vector ADs can be same vector, equal vector. So both are equal. So this is a way to prove the associative property of the vector addition. So multiplication of a vector by a scalar. एक vector को scalar में multiply करना है. So just multiplying only. If when you double कर लिया है, a vector को double कर लिया, 2 times of the vector. So 2 से multiply करना है. 2 into the vector r bar is equals to 2 into r bar. Okay. Half, suppose if you are taking this double in the reverse direction कर लिया है, -3 से multiply कर लिया and direction change कर लिया, so -3 into r bar. So we are multiplying the -3 which is scalar to the vector r bar. So vector को scalar multiplication, we call it as a multiplying the vector to the scalar. Okay. So this is a multiplication of the vector by a scalar. Any non-zero constant lambda, if you multiply lambda into r bar, you are going to get it. Lambda into r bar. So magnitude of lambda r bar is nothing but magnitude of lambda into r bar. So here magnitude of lambda into magnitude of r bar. Okay. Anurag, can you hear me?
Yes, sir.
So see that this with this a little bit easily you can understand. That's why I'm showing to you like this. And now here r bar and lambda r bar are collinear, parallel है actually. पैरेलल वेक्टर्स को कोलिनियर वेक्टर्स बोलते हैं, ये याद रखो normally, because we can remember in easiest way if I use the terminology parallel, so that's why I'm using the terminology as a parallel vectors. So r bar and lambda r bar are collinear. If lambda equal to -1, lambda r bar is equals to minus r bar. If lambda equals to additive inverse of the r bar, it is called as additive inverse of the vector r bar. So दोनों का ऐड कर लिए तो null vector you are going to get. Okay. Magnitude of the such type of the vector is equals to 1 if you get, and that vector is called as a unit vector whose magnitude is equals to 1 is called as a unit vector. A unit vector is represented as a r cap. We read it as a cap. R एक ऊपर ऐसा एक, that is nothing but r cap is a unit vector. It is a unit vector in the direction of the r1, r vector. So for any two scalars L and M and any two vectors M and N, L into A bar plus M into A bar if you are taking L plus A bar. Now multiplication of the vector by scalar that can be seen from here very clearly. And P is a point x comma y comma z, and P to A one perpendicular line is drawn on the xy plane. So the distance of the point P from the xy plane is x units, isn't it? And A to Q is y and A to S is z you are going to have normally. If you drop that perpendicular, x square you are going to get here, cuboid you are going to get here. P to A is actually z, sorry. P to A is z. Okay, and here O to Q is x, O to S is y, and O to R is z. O to R z means P to A also z only na. So that's why P to, when you drop the perpendicular from a point to the any plane xy plane, the other coordinate what you are not saying, that will be the distance. So z coordinate is nothing but distance of that particular point from the xy plane, and these are called OQ is represented by x into I cap. I cap OS is written as y into j cap. OZ is written as z into k cap. So where I cap, j cap, k cap are unit vectors in the direction of the x axis, y axis, z axis. And the position vector OP can be written as from the figure QA, Q to A, yj, and that is perpendicular. It is not showing to you as a perpendicular, but that is perpendicular. See that triangular law apply kar liya to, then it is not appearing to you as a perpendicular, but that will be perpendicular. Okay, OA is equals to xi plus yj you are going to get. OA is equals to xi plus yj, because QA is equals to, so from the figure AP is equals to A to P observe कर रहा, that is equals to वो भी perpendicular triangle OAP consider कर लो, वो perpendicular triangle right angle triangle है, because it is not showing to you as a right angle triangle, but it is a right angle triangle. Okay, OP is equals to xy plus yj plus zk. So the position vector form of the, this is called component form of the position vector. It is called a component form of the position vector xi plus yj plus z. And x y z को scalar components करते हैं और rectangular components बोलते हैं. In your textbook only scalar components word is used. And here direction cosines there. Okay, xi plus yj plus zk is called vector components. Okay, so now in a right angle triangle, O, suppose you observe that OQA is not looking like a right angle triangle, but it is a right angle triangle. Okay, so here whenever you are taking into consider that is perpendicular line whenever you are drawing here, magnitude of the OA square is written as x square plus y square, and in the same way OAP triangle if you are taking OP you are going to get it as a x square plus y square. Magnitude of the vector OP you are going to get it as a x square plus y square plus z square you are going to get. OP square is equals to x square plus means magnitude of that vector and whose components are given to you xi plus yj plus zk. Then that magnitude of that vector is equal to under root of x square plus y square plus z square. And it is making an alpha, beta, gamma degrees with the x-axis, y-axis, z-axis. Whenever it is taken that x-axis will be taken towards yours and y-axis right hand side, z-axis upwards. If you take a point like that will be taken. So L is equals to cos alpha, M is equals to cos beta, N is equals to cos gamma. These are direction cosines of the vector OP. Direction cosines के बारे में already we have learned it previously. Okay, so this is direction cosines, and the vector a bar whenever you are taking into consider it is represented as a li plus mj. Multiplication of the vector by the scalar I think you understood now. Vector is a bar is taken and it is ai a1i plus a2j plus a3k. Okay, and lambda whenever you are multiplying to this, and every vector is multiplied by lambda, every component is multiplied by lambda, and b bar is equals to if you are taking b1i plus b2j plus b3k, and this is a one vector, and if you add the vectors a bar and b bar means its corresponding components will be added. I ka components here a1, subtraction also in the same way, corresponding components will be added. So component form of the vector better you write every time whenever you write. So be careful that. And if two vectors are equal, their corresponding components will be equal. A1, A2, B1, A1 is equals to B1, A1 is equals to B1, and A2 equal to B2, A3 equal to B2. Collinear, if and only if there exists a scalar lambda such that both are equal, means product. One is means the ratio of the two components is same ratio if you are having. So a1i plus a2j, a1 is equals to some multiple of b1, a2 is equals to some multiple of b2. So the ratio, see I already told you, a1 by b1, a2 by b2, a3 by b3 is equals to some constant. Then that case we can call that as a polar vectors. And p1 and p2 are the two vectors. Distance between the 2 points is a formula if you are using, and OP is a P1 to P2 distance vector whenever you are finding. OP is a 1 and OQ is a 1, position vectors. Position vectors, है ना? So OP can be written as just like a O to P. So P1, P2 you are going to get in this triangle. OP1 is equals to perpendicular होगा. So triangular law यूज कर लिया तो OP2 is equals to O to P1 गया, P2 P2 गया, P1 to P2 गया. So they दोनों का addition. So P1 P2 is equals to OP2 minus P2. OP2 is nothing but OP2 can be written as x2i plus y2j component form when you are z2k. x1, x2, x1, x2, y2, z2 are the points whenever you are taking into consider. OP1 can be written as x1i, y1j, z1k. And OP2 can be written as x2i, y2j, z2k. समझ में आया ना ये बात? सो दोनों को सब्ट्रैक्ट करना है x2 minus x1i, y2 minus y1j, z2 minus z1k. Okay, p1 p2 if you want to find it, and magnitude of p1 p2 is nothing but minus कर लो, x2 minus x1i, y2 minus y1j, z2 minus z1k, and magnitude is nothing but अंडर रूट ऑफ x स्क्वायर प्लस y स्क्वायर प्लस z स्क्वायर आएगा. So like that अंडर रूट ऑफ x2 माइनस x1 होल स्क्वायर प्लस y2 माइनस y1 होल स्क्वायर प्लस z2 माइनस z1 होल स्क्वायर. ओके, समझ में आया? So next one is section formula. So that is nothing but O is a initial point and A is a 1 point. A is a 1 point. O to A if you are taking a 1 point and O to B is another point. The line segment AB is divided by the any other point in the ratio of A to B is a one line directed line segment. You can call it as a vector directed line. R is a point in the line directed line segment. AB is a one line segment AB. And OA we represent by that. Suppose it is divided by R divides the AB in M is to N ratio. R internally dividing point, and R if it is outside, R divides the AB externally. In the first case, R divides the AB internally. In second case, R divides the A internal case. R divides internally. In this case, how do we find out the point R? R position vector of the point. Let us consider the vector as a bar, O to A bar consider कर लो, O to B bar consider कर लो, O to R bar consider कर लो. And R bar we can find out if R divides the line segment AB in M is to N ratio. R bar is equals to yes, R divides the line segment AR to RB is equals to M is to N ratio. Then in the triangle OAR, O to A है and A to R है, and R bar can be OR can be written as OA and AR. AR can be written as A to R can be written as R bar minus A bar. A to R bar minus A bar, isn't it? In the same way, triangle ORB if you are taking, this RB can be written as OB minus OR, B bar minus A bar. These two things. Okay. So actually this is a proofs how do we get the vector R bar. So it is given that AR is to RB is equals to M is to N. So that is nothing but RB by AR is equals to AR by RB. Sorry, AR by RB is equals to M is to N. So that is nothing but when M into R bar. R bar is RB bar. RB bar is given B bar minus A bar. From this you are going to get a R bar vector as a M into B bar plus N into B bar by M plus N. Just like a internally dividing section formula. Mx2 plus nx1 by M plus N. So like that mx2, second vector is B bar, the first vector is A bar. So M into second vector plus N into first vector by M plus N. In the same way, you can take the externally dividing means minus आ जाएगा. If that point is midpoint, R is a midpoint, exactly mid में ले लिया है point. So 1:1 ratio and M and N values are equals to 1. So OR is equals to, you are going to get A bar plus B bar by 2. M and N are equal here. Isn't it? A bar plus B bar by 2. R is a midpoint, means midpoint vector if you want to find out. So that is nothing but A is a 1 point whose position vector is OA. B is another point whose position vector is B. R is a point externally dividing point. And in this situation, you are going to get it as a R bar. OR can be written as M into B bar minus N into A bar by M minus N. You are going to get that proof also you can see here. It's not necessary, just directly you can consider here. R bar is a vector. R divides the AB externally, such that AR is to BR is equals to M is to N. A to R is M, B to R is N. So in the bigger triangle, OR can be found out as a AR plus OA. So AR is equals to R bar minus A bar. समझ में आ रहा है ना? So ये just ये proof का जरूरत नहीं है, just you have to better you remember the formula here. What is the formula here? It is given to you that you write. Okay. So what is will be given to you here? M into B bar. Externally dividing is nothing but concept to understand. Through this figure easily you can concept understand. So both are equal. So substitute कर लो R bar minus A bar, R bar minus B bar substitute कर लो. Then you are going to get the required ratios whenever it is taken. Ratio is given. Okay. So this is the section formula. Externally and internally dividing whenever you are taking into consider. This is externally divided. Okay. Next here, actually dot product and cross product will be there, that we will learn in the next class. So now